Hello and welcome to a bonus, genuinely a puzzle pair of solves. Now, this was requested earlier today if I could take a look at the Philip Newman gas leak puzzles from early in February. So I've got zipper exoms and zipper sandwich because Philip has absolutely become in love with zipper lions recently, which honestly I'm more for than him and his weird German whispers obsession, but I'll take what I can get. Now, this is going to be a little bit more looser because I haven't really had time to figure these out yet. But we will do our best. Okay. Oh yeah. So hello. This is a bonus video. This is not a gas walkthrough. We are Team Gas. Genuinely approachable Sudoku. I am Bill. I often set puzzles. I solve them too. But yes, this is a a bonus walkthrough. If you want to find more of our slightly harder puzzles, you can find links to our Patreons on our website, which will be in the description below. You can also find links to puzzles like this, our gas leak puzzles. With that, let's get into it. So, alright, so let's go. This is a zipper lines exum. So we have some purple lines in the grid. These are zipper lines. This is this part. So what a zipper line is we can put a digit, whatever digit is in the middle, say a 7, then these two digits have to sum to 7. So like 2 and 5, and 1 and 6 as an example. For here, like it could be 8, 3, and 5, maybe. We don't know. We'll figure that one out. And then we also have X sums. Oh yeah, that's what all the purple lines in the grid are. The zipper lines will come back for the next puzzle. And these are X sums. So an X sum sums the first so many digits in the grid, where X is whatever the first digit seen by that cell is. So if this was 3, this could be like 2 and 4 as an example, because 3 plus 2 plus 4 is 9. That's it. That's all the rules. You can see how long it took me to do this, slowly trying to figure out how to explain it earlier. But with that, I'm going to get into it. So wish me luck. All right. So the first thing you should hopefully spot in this puzzle is 9 is pretty limited. If you have 4 as the first cell that this exum sees, it means it has to sum 3 cells, which is 1, 2, 3 at its absolute minimum. Plus the 4 means 6 plus 4 is 10. Breaks our exum. So the minimum that this can be is 2 and 3. Now, the other, both of those are 2 and 3. This is a tool that's going to come and help us. So, if this is 3, then what's this? If this is 3, then what's this? Now, there are 2 sums that sum to 9 with 3 digits. Now, if this one's 3, it could be, say, 4 and 2. Now, that breaks for multiple reasons. 4 would have to have a 2 and then a 1, which is bad. But also, it leaves this with no candidates, which is what's going to rule out our other thing. So the other thing is we need to make these 2 cells equal to 6. So as an example, 1 and 5. Now, that's sort of okay until you fill out the whole zipper line, and then 1 and 4, and then 3 and 2, and then once again, we have no candidates for that cell. So what that does mean is this is 2 and this is 7. I know that this must be either 8 or 9. And now I can actually do a little bit of logic. If this was 9, then 7 plus what makes 9? 2. Oh, that breaks. So, why do I know it's 8 and 9? It's because whatever's in the middle of the zip line needs to be bigger than any of the digits on the outside, which is a point I'm going to come back to probably a little bit later in this puzzle. So, we now know that this must be 3. And if this is 3, it can't be 2, 4, because I would need to repeat 2s like I just proved. So this is 1 and 5, meaning this is 4 and 2. Now, I can put a 5 here and a 4 and a 9 there. Now, 6, 7, 8, 9 here, but we'll put the 9 in because the sum of 9 cells in a Sudoku grid comes to 45. Yeah. I hope you knew that. If you didn't, that's the secret. So this is 2, 6, 7, and 8. I can never put the smallest digit there, and then I can never put the biggest one there. Pardon me, I am coming down with a sore throat. Now, this digit needs to be bigger than whatever the lowest digit is. That's 7 or 8, meaning this cannot be 8. But let's do 24. Okay, so what is the lowest that a 24 could be? It can be a 4. It can be a 5. It can be a 6. It cannot be a 7, because the first 7 digits, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, is 28. Now, all right, let's do some logic. Okay, so if this was 6 cells, that would have to be 24. And then this would have to be 26 plus 19. Could not work. So it either has to be 4 or 5. Now, I have a sneaking suspicion this is about to break as soon as I put a 4 in here. So this has to be equal to 20. Oh god, hang on, I know why this breaks, and it's killing me. No, it's, oh. Okay, I'll come back to it. I do know something for a fact, and this has to be 6. Why does that have to be 6? Now, the reason why that has to be 6 is the lowest that a x sum for 30 can be is if it's 5, because 4 would need to sum up 7, 8, and 9, which is 24, plus 4 is 28. Can't be 5 because we have a 5 in a row. This is 7 and 8, and 9 would be 45. So, because we have 6 there, we know that this is an x sum for 30. Now, because we know that that's an x sum for 30, these 7 cells add up to 35, meaning these two have to add up to 10. That's pretty good, because we know that that's an 8 and that's 2 now. Zipper line here, if this was a 6, I'd have to put a 2 here, so that's a 7 and then a 1. Putting a 6 here. Now, what is this? What's this cell? The center digit on a on this zipper line. Can't be 9 because we already have the 9 here. It can't be 6. So 8 or 7, 6 could not be 5. It could not be 5 because if this was 5, this would have to be 4, meaning these two would sum to 9, meaning this would have to be made up of 15, which is possible in Sudoku, but those digits would have to be less than 5, which you cannot do with 2 cells. So this cannot be 5 anymore. Now, okay. Um, 7 or 8. Okay. It's kind of killing me. All right. I feel like this will. I know that this is not 4, and I know it's. Oh, I think this actually does have to be 4, but I'm trying to remember how I proved this. Oh, wait, hang on. Much easier. Much easier. What's. Oh, wait, no. Oh, I'm gonna beat myself up. Alright, so. This is. This is 4, then this can't be 8, so that has to be 7. Meaning that's 3. Oh, that just breaks. Okay, sure. Reason that breaks is, what is this? Because it can't be 3, 4, can't be 1, 6, and it can't be 2, 5. So, have that as 4, so this has to be 5. Now, this can't be 7, because 7 needs a 2 there, so that has to be 8. That's 3. And if you're like, Bill, was that bifurcation? The answer is, this is the sort of coping strategies I've had to develop when testing Philip Newman puzzles. So I hope you'll excuse me. Sorry, Philip. Oh, okay, what is this? This is 1, 3, 5, or 9. Can't have a 1 here, can't have a 5 here. Ah, yes, I remember. This can't be 9. Now, if this was 9, this would have to be 5, which would break because I'd put a 4. I can't put a 4 there. So this can't be 9. The digit in the middle cannot be smaller, so this has to be 5, then 3, then 2. And take 3 out of there. 8, 9, 3, 4, and 7. Now, this can only be 4, 5, or 6. Can't be 5, and it can't be 4 because if I had a 4, I would need to put a 1, 3 pair, but I already have a 3 there. So this must be 6. Now, this is 1, 2, 4, or 5. Take the 5 out of there, 1 there. Oh, it's killing me. It's killing me. Alright. Alright, let's do some more Sudoku. No, that's not even right. Okay. I think this can't be 8. Now, if this was 8, this would have to be 1 or 2. Oh, no, that's not right. I think I'm bifurcating. I think I'm now bifurcating. That has to be 2 and 6. That's 2 and 6. Which would put, that is 7, 6, 2. No, that's bifurcation. Let's back it up. I did this puzzle earlier and I am struggling to remember what's up. Okay. I would love to blame illness for this one. Oh, what's that? What's that? That's the highest. What is the highest that one can be? Because it can't be 9, 6, 7, or 8. So it has to be either 3, 4, or 5. Oh, meaning that's just 1. Okay. Now this is 2, 3, 4, or 5. Yeah, I'm starting to get it. This can't have a 5 on it. Now this has to be 1, 2, 3, or 4. Now, alright. So, if this is 7, this would need to have a 3 or a 4. Or a 5, which it can't have. Now, if this was an 8, it would need to have either a 2 and a 6. So I'll put a 6 in. 3 and a 5, and 4 would just break. Okay. Now, alright, and then here, this has to be either 1 or 2. Okay. Sure. Okay. So, I hope this is interesting. It is a difficult puzzle. Okay. For what it's worth, the sandwich Sudoku that comes after this is marginally easier, I think. This was... Oh, right. Sorry, I forgot this bit. If this is 6... Yeah. For what it's worth, I had this issue when I did solve it. I have just remembered what I've forgotten. This X sum is how this puzzle starts unwinding properly. Now, if this is 6, as an example, then this has to be 1 and 3. Now, yes, I know. So that's 2, but then these, because I can't put a 1, meaning this is 8. Now, because the only way I can make that reach 8 is if both of those were 4, which would break. So, we know that that's not 6. This is 7. So, this is 8 and 1. X sums tells us that law of leftovers means that's a 4, taking 2 and 4 out of here. This is 6 and 2 now, so that's 6. We'll take 2 out of there, 3 out of there, 1 out of there. Now the minimum that this can be is 5, so that's 2, 3, and 5. 4, 8, 9, and 4. I haven't even filled it in yet, but I'll do that in a second. That's 5, 6, because this is 5 and 1, 7 and 1, 9 and 1. Alright, 2, 3, and 9 to go. That's 2, that's 2, that's 9, that's 3. That's 9. This is 4 and 8 left to place. This is 2, 3, and 5. No, 3, 5, and 7. We can't quite do that yet. This is 3, 7, and 9. This is 2 and 8, which I can do because there's a 2 in row 5. And this becomes 4, 6, and 7. Now, I need to put a 1 here, so that's where that goes. Now, what do I still have to place? If I take 3 out of there, 9 out of there, 4 out of here, and 6 out of here, that leaves me with 4, 6, 7, and 9. The only 2 consecutive digits, because they have to add a 1, is 6 and 7. Meaning I can resolve all those boxes. We'll take both of the 7s out of here, and this is now 3, 5, and 8 to place. Can't quite do that just yet. So this is 2, 4, and 9, which I absolutely can do every single one of them, and that should unwind this whole puzzle. 8, 4, 8, 9, 3, 7, 4, 3, 5, 8, 3, 5, and 7. It was not 15 minutes. How long have I been talking for? That was 20 minutes? Jesus. Oh no, this one's going to be a long one. All right. Hopefully this will be a little bit nicer. This is zipper sandwich. So the same zipper line rules apply here. But these are sandwich clues. So sandwiches digits between 1 and 9 those digits must sum to that total. That's it. Now, I subconsciously do remember how to get going on this puzzle, which is indicative of I had a shorter time on this one. Now, 33 clue means that if you subtract 10 from 45, it is 35. Now, once you take the only digit that you can out of that, you're left with 2. So we know that we're going to essentially have like one outside cell, and then the rest. So it could be any combination of like 1, 9, and 2. I could swap these 1s and 9s around, make that 9 that 1. Likewise, this could be 1, this could be 9, and that could be 2. But I know that all those digits can't have 1 or 9, right? That's just a thing that we know about sandwich Sudoku. Sort of like if you were doing a sandwich, you could color it in like, hey, these cells have 1 and 9. If that was, normally how we'd go, but the whole point of this puzzle is to get started without having to color. Now, of those green cells, which of these can have the digit 9 in them? And it's this one, right there. 9 and 1. How do I know that? Because on a zipper line, these two digits have to sum to the middle digit. Now, 9 plus anything is going to be bigger than 1 digit. This line, this one, and this one all reside on a zipper line. Similarly, we can actually just put this 9 down here too. So let's do that. Now, so I'm going to put my 9 there. This is 2. This is 1. And that is... Oh, I'm kind of getting ahead of myself, actually. So apologies for that. Now, 32 needs to have the same sort of thing, but because it's instead of 2, we're putting 3 on the outside. Now, this has to be. Oh God, hang on. So, like, once again, I cannot put it on these 4 cells. So, of 5 cells. So I need to put a 9 in this box, and it needs to go here because it cannot go on the zipper line on the end of it. Meaning 1, 1, and 3. So 31 has the exact same problem. Now for 31, I need to place a 1 and a 9. Now I cannot put a 1 and a 9 here. Meaning, because it is now 2, 3, 5, 6, 7, 8, it needs 2, 3, 5, 6, 7, 8. Or here, those cells will have to be 2, 3, 5, 6, 7, 8. Meaning this has to be 1 and this has to be 9, because this is on the end of a zip line. We know which way around it goes, 1 and then 9. Now, 30, we could have a 2 and a 3 on the outside. That is a possibility. I don't exactly remember how to prove it. I mean, it's 9, I believe. Well, I'm going to just plug it in and see what happens. 2, 3, which would mean this have to be 1 and 9, and this, yeah, cool. Feel like, what's he on about? Okay. So, what's this digit? Well, 4, 5, 6, 7, 8. The lowest that these two cells can be is 4 and 5, which would be 9, which I cannot place anymore. That's my excuse for just cheekily writing in 1 and 9 right there. Now, that does mean I can do 4 here, 5 here. Now, this cell cannot be 8 because I would need to place 2 4s there. It cannot be 6 because I've already used a 1 here. So this must be 7, allowing me to write 3 and 2 here. This is now 6 and 8. Alright, now this has to be 6, 7, or 8. Oh, it's not very useful right now. Alright. This can be as low as 7 or 8. If this is 7, this has to be 4 and 5. If this is 8, this has to be 5 and 6. Cool, that 5 there breaks this. So this has to be 4, meaning this is 7, and this is 5. Putting a 6-8 pair down there. Now, what can this be? Can't be a lot of things, actually. So, oh god. This is 6, 7, 8. I'm just gonna do a little bit of that cheeky stuff. I'll take the 7 out of there. Now this can't be 3, 4, 5. It can't be 4 or 5, meaning I can take 5 and 6 out of there. Alright, let's go over here. What's this? Is that where I wanted to look? I don't really recall. 2, 3, 6, and 8. Oh, that's pretty good. This can't be 2. It can't be 3 because this can't be 3 because that would need me to put a 2 there. So I can take 3 out of there. This can't be a 6 because it would need me to put a 5 there. So this is 8 and this is 7, which allows me to do some damage. I need to put a 9 here. And then this puts a 8 here, 6 here. This is 4 and 6, which, thank you to my work over here, helps me resolve this. 6 and 4, there we go. 6, 8. We'll take 6 out of here. 4, 7, and 8. 2, 3, and 5. Cool. This cannot be 4 because if this was 4, I would need to put a... this can't be 4 because there's only one way of summing the 4 using 2 digits in a Sudoku, not 2. This can't be 4 because 2 would need to have a 2 there, and 4 is less than 5. So I'll take 4 out of there and put 4 in there. 8 and 7. We can do some more damage. 2 there. 3, 6 here, meaning this is 1, 7 and 8th place. 8, 1, 7, 2, 3, 4, 6. Where does 6 go in column 2? It must go here. This is now 4, 5, or 6. Beautiful. Love that. 2, 3, 4. Oh, beautiful. Wait, no, that's not right. It's 3, 4, 5. I'm never that lucky. Now this is 2, 7, or 8. 2 absolutely cannot go on a zipper line, so we'll put that there. This becomes 3. We'll take 3 out of that. Take 3 out of here. Now, if this is 8, I can't quite do that just yet. So if this is 8, this would need to be 3, 5, and if this was 7, it would need to be 2 and 4, but it can't be 4 because it's in the same row. If this was 8, this would need to be 7 and yeah, if that was 8, that would need to be 7. And if this was 8, this would need to be 5. Oh, beautiful. Okay, so if this is 8, this breaks because 8 can't have a 5 there because we've already got a 5 in the row. 8 can't place 2 4s. So that tells us that this is actually 7. Put an 8 there, take the 2 out. We know that this is a 3 4, but this has to be 6, 2, 8, 6. Now this is 2 and 7, and this is 1, 4, 5, and 9. Well, I'm not going to pencil mark that. I'm being lazy. Oh, but those are the only 2 places for 3 in the grid, meaning this has to be 2 and then 3. Still not really useful, but let's try this. Alright, I'm gonna pencil mark. I'm gonna go fishing. I'm not calling it bifurcating or recklessly pencil marking. I'm calling it going fishing. So if this was 7, this would have to be 2 and 5, which is both fine. If this was 8, this would need to be 3 and 6. This can't be 3. That's fine, we'll get that. If this was 8, this would need to be 7, and this is 5. And if this was 7, this would need to be 6. Oh, okay, cool. So because of that, we know that this cannot be 7, so this is 8. 5, 3, 7, 2, 5, 2, 7, 4, 6, 7, 2, 1, 7, 1, 3, and 9. 4, 6, 4, 6. Well, this has been a long video. If you have stuck it out with me till the bitter end, thank you. Love you. Have a lovely day. But these have been a couple of gas leak puzzles. Please check out our website if you would like more puzzles like this. We don't just do easy ones, we do mischievous ones too. And I love that for us. But for now, have a lovely day. And I'll see you next time. Bye for now.